Hi everybody, it's Roy here from Astro Ventures and Battlestones Observatory, and I'll talk to you very quickly for 3 or 4 minutes about when stars near the end of their lives and when they either supernova or nova and what's going on with that. Well, last year, you may remember in the news, we were talking about the star Betelgeuse, or Betelgeuse or Betelgeuse. I like calling it Betelgeuse, who doesn't? Don't say it 3 times though. This star dimmed quite a lot last year, and a lot of people were thinking that it might blow up. Certainly that was what was reported in the press. And there were other things that happening at the time and other observations that told most of us that that wasn't going to happen. It's not really at that point yet. But when it does get to that point, what will happen is, imagine a great big giant star like this. This is football, obviously it's not red, but pretend this is a great big red giant star. What's going on is you've got a nuclear reaction in the middle which is producing pressure, pushing the star outwards, trying to make the star expand and blow up and so on. And then you've also got a gravitational force holding that material together. Gravity's trying to collapse the star, the nuclear pressure is trying to push it out, and in every star that you see, the vast majority of them, that's a balanced force situation. So the star just sits and burns and gives off heat and light, just like our sun. Our sun's doing that right now, and it's going to happily do that for another 4.5-ish billion years. Okay. When the nuclear material in the centre of that star, particularly the red giant star we were just talking about, when that runs out, that nuclear reaction stops. It stops dead. Gravity takes over and the star collapses, and that happens at such a speed and with so much energy that as it collapses it then explodes and you get a supernova, the kind that you see in movies and films and so on. Now the other type of supernova happens when you get a big star, could be a big main sequence or a giant red star, orbiting around a white dwarf, well, orbiting around each other, I guess, like this. And the white dwarf is what you get left over when a star roughly about as big as our sun ends its life. It's the core of the star. So imagine our sun's going to end about 4.5 billion, 5 billion years, maybe a bit longer than that actually, probably on a Monday morning, let's face it. And all the outer layers will drift off at vast speed into space, and what remains will be the core of our sun. And that's a white dwarf. That's what a white dwarf is. White dwarfs can only get so big though. Now depending on whether the white dwarf itself is spinning and how fast it's spinning, they can get to about 1.4, 1.5 times the mass of the sun. When that happens, the white dwarf becomes unstable. So in a situation where you've got the red giant or the big star, the big super massive star or the main sequence star and the white dwarf orbiting each other, the white dwarf is pulling material off the big star next to it, and the white dwarf is gaining mass and getting bigger. And actually what will happen at some point is another nuclear reaction will start in this white dwarf, which has actually been up until now dead. When that nuclear reaction happens, you get a nova. It's a lot of energy given off, and that's what's happened in this star near Cassiopeia over the last few days over the weekend. It hasn't died like in a supernova, it's just brightened up and produced this nova. What will happen over the course of a few weeks, months, years, is that material, a lot of it will kind of drift off into space, and you might get this beautiful telescopically observable object that looks wonderful, but some of the material stays on the white dwarf, and its mass increases. So in this situation, the white dwarf can go through several novas over maybe decades or centuries until there's enough mass on the white dwarf for it to reach the Chandrasekhar limit. And at that point, it'll explode, it will go supernova. So what's happened with this star over the course of the weekend is just a nova, but it's in its death throes. It might nova a few more times in the next few decades or hundreds of years, and then it'll eventually supernova, probably. And this is a very oversimplistic explanation of that process. But it's beautiful, it's bright, and if you can get the binoculars on it and the telescope on it, then you'll see this new kind of dot in the sky. And I don't think it's going to end up supernovaing during our lifetimes. That would be fantastic if it did. We could see that and it would be amazing. But these things are reasonably common. So who knows? Who knows when the next one's going to happen and what that will look like. So anyway, listen, I hope that explains a little bit about the differences between when a star supernovas and dies immediately, and novas doesn't die there and then, but is on its way to dying, and it's going to happen, over the course of the next couple of 100 years maybe. I hope that explains that a little bit. I would suggest if you want to learn more about this, get onto Wikipedia, get onto YouTube, look up lots of really flashy, wonderful videos on supernova and nova, or ask questions in the comments below and I'll try and answer them if I can. And watch this star, watch it over the next few weeks. It'll perhaps brighten, it'll perhaps dim. And that'll be really interesting to see. If you are an astrophotographer, image it, take pictures, and then compare those pictures over time, maybe put a little video or GIF together like we've done, and just basically see what's happened with that, okay? Please like this video and subscribe to this channel, especially looking as we're going to be doing much more kind of observing and content and tutorials over the coming months and next couple of years, okay? Take care everybody, bye.